Hello and welcome to PAS Virtual Summit 2020. My name is James McGillivray. Today we're going to be talking about the fundamentals of DAX contexts. But before we get started, a couple of messages from the Virtual Summit. Firstly, PAS is so much more than just the summit. It's a great organization which provides a huge amount of resources, a huge number of resources for your learning and your growing as a data professional. And we really invite you and implore you to explore all the various options and things that PAS has available. A lot of it is free. A lot of these resources are there. They're available for you to use at any time for free. There are also obviously our free in-person events, SQL Saturday, which hopefully are going to be coming back soonish. Hopefully the pandemic will be over and we'll be able to have in-person events again. But until we do, a lot of SQL Saturdays are being hosted virtually. And then, of course, all the virtual groups and the various other offerings that PAS has. Please explore those, take advantage of these resources. Then also importantly, please, at the end of this, at the end of the summit, at the end of each session, submit your session evaluations. It really helps the organizers and the speakers to know what went right, what went wrong, what could have been better, and what your experience is. After all, you're here to learn and to get the best experience, and we can only know how to make that better and how to do that if we get these feedbacks. So please fill in your evaluations, and as an incentive, there's some prizes if you fill it in by the end of the week. So please do that. A little bit about me. My name is James. As I said, I'm from South Africa. I work for part owner and company called Cobalt Analytics, and we specialize in Power BI, data architecture, and data warehousing. Outside of that, outside of work, I like to play sport. I like to play other kinds of games like poker and board games, and I really love to travel. And you'll see some photos that I've taken on my travels this year as part of this talk. So what exactly is it that we're hoping to achieve in this session? Well, what we'd like to do is we'd like to start at the very beginning with a little bit of theory. So I'm going to take you through a couple of concepts. I'm going to explain things in theory with some slides and that, but all of us know that theory isn't really the most interesting thing. So what we'll actually do is we'll try and visualize those concepts in the slideshow itself. So we won't go into Power BI just yet. We're actually going to take our data set and we're going to look at a visual data set and see what happens as various things change and as we explore the various things that we're learning. And once we've seen those things happening in the slideshow where I can control the speed and what's actually going on, then we'll move into Power BI. And in Power BI, we'll actually just play with some data sets, look at some demos, and explore these concepts that we've learned as we've gone along in the session. Okay, so what exactly are these concepts that I'm talking about? Well, we are going to start with evaluation context. So what is evaluation context? Just a very brief overview before we do anything about what the session is about. After that, we're going to look at the data set and become familiar with it before we start actually manipulating it and using it to display some examples. Once we've done that, we'll move on to filter context. Now, filter context is one of the two evaluation contexts. So we'll learn about that. We'll build on that knowledge by going to the other context, which is called row context. We'll work through the row context, and then we'll start using these two concepts that we've learned to start manipulating our data and start seeing the power of these DAX contexts and what they can do for our data models. So we'll look at the calculate function and we will start creating new filter contexts and playing around with that function. And then after that, we're going to look at a couple of other things we can do, modifying relationships in our data model. We're also going to then look very briefly, because this is starting to get sort of more advanced, to context transitions, which is switching a row context into a filter context. And then we are going to play around in Power BI with one or two more examples and just sort of seeing what happens, maybe looking at a couple of best practices, worst practices, things that go right and wrong. And then after that, we'll have a little bit of time for questions, and I'll be online. I'll be there to answer any questions that I can and help you guys out. Hopefully you enjoy the session and hopefully you learn something. So let's start with the most basic question of all. What is an evaluation context? Well, to get to the answer of this question, we need to understand a little bit of theory. Why do we need to understand this? Well, as soon as you want to do anything a little bit more complicated in DAX, it's very critical that you understand exactly what's going on under the hood. And that's exactly why we've put this session together. And that's exactly why I hope you're here to learn, is so that you can move into a little bit more advanced stuff and get a bit more familiar, a little bit more comfortable with that. And the reason we have this session, and the reason I'm going to take it quite slowly to start with, is because all of this is quite intuitive. All of it should make sense very quickly. But then suddenly you will not understand, or suddenly we run into roadblocks where we don't exactly understand what's going on and why our formulas aren't working the way we expect them to. So what we're going to try and do is we're going to try and get a really, really solid knowledge in the beginning, get that clear in our brains, get it really, really go through it step by step and understand exactly what's going on, so that hopefully when we move to the little bit more complex stuff, we can really visualize that actually happening. So the first question, and the biggest question, is, have you ever found yourself sitting maybe on an anthill, maybe in an office chair, wondering to yourself, how is the same DAX formula able to return different results without us doing anything? You know, if we want to do something in Excel, we have to tell it, look at this range of cells and perform this operation for me. Or we have to write really long formula, complicated sum, if this, and then that type of thing to create lots of subtotals and that. In DAX, we don't do anything like that. We write a really simple measure, we plug it into our report, and suddenly we get multiple values from it. Now, the answer to that question, probably unsurprisingly, is evaluation context. It's the whole purpose of what we're going to be talking about. But the real theory answer is that every single data point in your tabular model or in your Power BI report or your Excel calculator, whatever it is that's actually leveraging this DAX, every single data point is calculated using its own evaluation context. So the same formula, the same measure can bring back multiple different results depending on the context in which it is calculated or evaluated. So there are two parts to this. I kind of touched on this in the introduction, and we're still actually only going to touch on it right now. There will be one section on each of these two parts as we go forward. But for now, there are two things that happen when the evaluation contexts are actually calculated. The first one is that the data set is filtered. It is made smaller depending on what it is that we're trying to calculate. And there are a number of different ways that this happens. So the filter context reduces the data set and reduces the number of rows over which our calculation takes place. The row context basically iterates through each row in our new data set, the one that has been filtered first. It iterates through the data set and it performs the calculation. So the theory part, or the important thing that I want to sort of demonstrate on this slide, is that the evaluation context, or the result that you see in your model, is made up of the filter context plus the row context. But they are not the same thing. They are not subsets of each other. They are two different things altogether. And it's very important to keep that distinction in mind as we move forward. So the filter context actually reduces the data set. The row context goes through it row by row to produce a calculation. Filter context filters, row context iterates, and that means that filter context does not iterate, row context does not filter. Cool. So we're happy with that. That is now the very basis of our knowledge. So we're going to add just a little bit more to this theory slide. There are two contexts. They are not the same. They are both, each calculation takes place with both contexts. And then every value in any output format, whether it's in Power BI, whether it's in SSAS or Tabular, whether it's in Excel, anywhere where DAX is producing a number or a result for us, each one of these things is has its own evaluation context, and each value is calculated independently in that evaluation context. Well, before we start digging into the details of these various things and learning about them, we're going to move into our data set, have a look at what it is that we're going to be playing around with. Here is a data set. Okay, this is basically a table. I find it quite difficult to think in a table, think in this sort of way. So what I'm going to do is I'm actually going to show you this data set like that. This is a data set of 12 photographs. Okay, it's very small, obviously, for the purposes of this presentation, but we have 12 photographs. Each one of them has something to do with an animal. But I don't expect you to know necessarily who's who. So the first character or the first attribute in our table, first column, is actually a photograph name, and the photograph name gives us a little bit of detail about which animals they are specifically referring to. But in addition to just having the name, we also have an actual link to an animal table. So we have an animal key, and we're using a nice little dimensional model here where we have our animal dimension that has a class of animal and the actual animal itself. And each record in our data set links to that through the key. Okay, then we also have a category, a photograph category, and the category in this case is the wildlife or sports, and within each of those categories there are subcategories in terms of either the sport that is being represented or the type of animal, sort of the class of animal. So we've just got a little bit here of a couple of relationships, and we need this in our model because we're going to explore the effect of relationships in the DAX contexts as we go along. And then we have another set of attributes to do with the photograph, which is actually stored on our fact table, as it were, or our main table. And that is basically the time of day in which the photograph was taken, what type of photograph it is it an amateur or professional photograph, what is the primary color of the subject of the photograph, what is the primary color of the background of the photograph, what is how good or the rating of the subject. And I must just sort of at this point say these are my ratings that I've just kind of thrown together. They're not really representative of anything else. I had to give some different values so that we could play around with these values as we work through the data set. We've also rated the background, so something that has a really beautiful background like the photo of the leopard in the bottom right hand corner is better than maybe something with a fairly bland crowd background like the photo of the rugby, which is the red one in the second row. And then the last field that we're going to sort of talk about is the number of subjects in the photograph. So some of our photographs have lots of subjects, like this one over here, and some of our photographs have a single subject, like the lion and the dolphin over there. So here we have a data set. Now, hopefully you can sort of see that, and it's not going to be very difficult for me when I say that I want to look at a specific subset of this photograph, because you'll be able to see them as we go along. So just for that, let's have a quick look at what is our Power BI model or our tabular model look like under the hood. Well, we've already talked about it. We have two outlying tables, or two dimensions, and then one fact in the middle. And they link very nicely one-to-many relationships, the way we are supposed to model for best performance. Okay, so we'll touch back to that when we look at the actual demo. But the kind of questions we're going to ask of our data set, because at the end of the day, all of these, the reason we write models, data models, is to be able to ask questions of our data and get answers. So the kind of questions we're going to ask are, how many images are there? Or how many total subjects are there in the images? Or what's the average rating? What's the highest background rating? So we've got a couple of simple questions here. And if you've worked in DAX at all, I'm sure you can already imagine how we're going to do that. But very simple measures, things like count rows in the table, sum, average, or max. So all of these very standard DAX measures that we're going to create, but you're going to see as we move through what's actually going on under the hood. So let's talk now about filter context. So hopefully you sort of are now, you've got an idea of what the kind of thing we're going to do with this data set is. So let's talk about filter context. So back to the theory. Well, filter context determines the underlying data set on which a calculation takes place. Okay, so filter context, I've kind of said this already, but filter context basically is going to reduce our data set to a set of rows, and then we're going to perform the calculation on it. So even when we don't have any filters as such, we still have a filter context. So in this case, we have the filter context of no filters. Nothing is, we're not reducing our data set at all. We have the entire data set. And when we do that, we can already start asking our questions. So how many images are there in our entire data set? Well, 12. How many total subjects are there? Well, we basically get the subjects column and we sum it up and we get the total number of subjects is 57. What's the average rating? Brings us back a result. And what's the highest background rating? Again, brings us back a result. So all of these values are calculated within their own filter context. And in this specific case, the filter context is the entire data set. It is the simplest filter context there can be because there's really nothing happening here. We're just summing up all the values or getting the maximum or getting an average, etc., etc. So now we've got to ask ourselves, so what can introduce a different filter context? What can affect the filter context? And the first thing is, unsurprisingly, filters. So if you in Power BI or wherever add in book level filters, page level filters, visual level filters, they will all affect the context of the calculations that will take place. So very intuitively, if you add a filter context, if you add a filter to your Power BI report, you expect the value to change. You expect the rows, the number of rows to change in your data set because, well, you're filtering them out. And then, of course, filters are outside of a report. They are applied, on the outside of the report. We can also have filtering devices within our reports or objects that allow us to filter the reports at runtime, and that could be maybe our slicers. And slicers, for all intents and purposes, behave exactly the same as filters, which is why I've grouped them together for this first little chat. And slicers do exactly the same thing. They will, as we make a selection there, they will filter the data set down. Enough waffling. Let's have a look at some filter contexts and see what happens. So let's assume we've got our data set here. We've got our number of photos measure that we're looking at, and we are going to now add a filter. So the first thing we're going to do, we're going to add a filter onto the time of day column. You can see that in Power BI there, I've added a little filter on the side and I've selected morning and afternoon only. So what happens when we do that? As we make those two selections, well, basically we remove those anything that is not afternoon or morning from our data set. So that so we had 12 photographs. When we click on afternoon and morning, it reduces it to a data set of 6 photographs, and those 6 photographs then get counted. And strangely, counting to 6 brings you the result of 6. So counting 6 rows brings us back this value of 6. So what's happening there is that the filter context itself actually creates a new data set, which is just a smaller version of the old data set, and then performs the operation. So we've now looked at the two basic ones, which are filters and slices, but there are a number of other times where the filter context is modified. And this is one that maybe is not so intuitive. This is something that we actually have to think about. So within a visual, we can also create filter contexts. Note, I didn't say a filter context. We create multiple filter contexts within a single visual because there are multiple points that need to have their own calculated value. So again, let's have a look at maybe here we've created a visual and we've already put it into Power BI. And this visual is basically the primary color of the subject. So we're counting how many photos have a primary color of white, how many photos have a primary color of gold, etc., etc. So it's easy to look at that and for us to go, oh, okay, well, what we do is we start with white and then we go through our entire data set and we go no, 1, no, 2 type of thing. But that's not really what's happening. What's actually happening is that the data set is being filtered. So for the white value, we actually filter to that data set of those 5 photographs and bring back that result, perform the operation. Then we move on to the next one and we filter down to that data set for gold, etc. So actually what's happening here is we are creating multiple contexts, multiple filter contexts within one visual. And for each filter context, we are actually calculating the value by reducing the data set, performing the operation, bringing back the value, etc., etc. Okay, so we've basically touched on now how filter context is happening, and hopefully you're feeling very comfortable and very confident that you understand exactly what's going on. Because the next thing we need to think about now is what happens if we change that visual into a table? This is still a visual within Power BI, and we still have unique filter contexts for each of the values. So when we look at white, this white is calculated exactly the same way as the white was in our previous example where we had the graph. That white will still be reducing the data set to 5 rows and counting them, reducing the gold to 2 rows and counting them. And then the interesting question is, what happens when we get to our total row? So we have a total row, and the total row here is bringing back the answer of 12. And it's very simple, again, to think about this as being, well, what's happening with that 12? It's 5 plus 2 plus 1 plus 1 plus 1. That is not, in fact, what's happening. The total row actually creates its own filter context, and the filter context for that total row is no filters, like we had originally. And that's how we bring back this value of 12. So our value of 12 actually comes from its own filter context of 12 photographs and then counting all of them. Okay, so basically that's all we need to, oh, sorry, there's one more thing. There is another thing that can happen in Power BI, and this is Power BI specific. You can't do this in Excel or in another tool so much. But within Power BI, we also have the ability to click within a visual or within a table, wherever it is, to click on a value and get interactive results back. So we've got these external visuals that can affect our data sets. And that's a little bit difficult to think about. So maybe let's look at an example again. So we know that the average subject rating for our entire data set is 12 rows. Okay? Our average rating is 3.75. It includes all 12 rows. That's what I meant to say. Okay. We can then add in another. So that's a card on our report that we're looking at right now. We can then add in another visual, And that specific visual would be maybe the number of photos by the time of day. So within that visual, it creates 4 new filter contexts. Okay, so we've got 4 new filter contexts, night, afternoon, morning, and midday, and each one of them filters down to its own data set. But they don't affect this card. This card stays as a single data set. And that is the entire data set of 12. But then what happens is we click on one of the values. So in this case, we've clicked on afternoon, and we are then moving forward. We click on afternoon, and then something happens because then our value changes. So we've got to think about what actually happens when we click on afternoon. Well, we filter down to afternoon and create a new filter context because that's what we're doing. We're now getting familiar with this pattern. And that filter context then brings back this value of 4. Okay, so we add 5 plus 4 plus 3 divided by 3, and we bring back the value of 4. That's the average rating for those three photographs. So now what's actually happening is that the filter contexts within this specific visual are now being used to determine the filter context of this visual. So the selection I've made here, where I've clicked on 3, is actually affecting the filter context under which another calculation is taking place. And it's probably easier to see this one in Power BI itself. So that's what we're going to do in a second. But just so you know, that same filter context that happens when you use a slicer, the same filter context what happens inside a visual is also happening in this specific situation. So let's have a look at some demos now. As I said, we're going to go into Power BI. I'm going to play around with a couple of demos. We're not going to be here for very long, and then we'll come back and do a recap of filter context. So here we have a Power BI report that I've just put together. Now, actually, it's almost exactly the things we've been talking about. We've got our 4 measures over here in our cards. We have the number of photos by subject color that we were talking about earlier, and we've got a bunch of slices on the right-hand side. So the first thing we're going to talk about, we're just going to have a look at how filters affect our data set. So the first thing we can do is we can maybe bring in a time of day, because that's the one we looked at earlier. We've got our selections here, and we're going to choose afternoon and morning because that's what happens. And you can see exactly what we were talking about earlier going on here now. So our data set has actually been filtered down to 6 rows. That's the data set itself. We have each one of our calculations is respecting those 6 rows. We talked about this 23 earlier in the visual example, and each one of these visuals is affected by the filter context. Additionally, inside this visual, the number of photos by primary subject color visual, we have an additional filter context because we're still respecting the colors. We're still adding in the filter context of the various colors to this filter context that we first applied, which is the time of day. So we've only got 6 photographs here, but we still have the 4 photos. And the nice thing is that we've built in a little tooltip which shows us which are the underlying rows that make up the filter context in each specific situation. And it's quite easy to see because it's obviously the color on this photograph. So what happens, as I said earlier, when we click on those are our that's using a filter. The other thing we can do, of course, we can use a slicer. And again, we had afternoon and morning. We can play around, and you can see that we bring back the exact same set of data as we did when we used the filters. Filters and slicers perform exactly the same operation. They're filtering the entire data set. So, couple of things, really important points about filter context. Firstly, every single data point is calculated with its own filter context. Then total calculations have an explicit filter context. We've talked about this earlier. It's not the sum of all of the underlying parts. They are calculated independently, autonomously, and on their own with a data set that basically just removes certain slices that are acting on the subcategories. Filter context respects explicit relationship. Filter context is cumulative. So as we add in new filters, you saw this when we were talking about the filters within the visual. Within the visual, we already had all of the filters that were acting on the entire page, plus for each point within the visual, each category within the visual, we had an additional filter context, which was the actual color that we were looking at. Filter context is evaluated first. This is fairly intuitive. The first thing we do, we get down to the right data set before we start performing our actual operation. And then the last thing is, this is how we get from one formula to many different results. Filter context is the critical first step of how we go from one formula to many different results. So hopefully you now feel comfortable with filter context, because now we're going to move on to the next section, which is actually row context. So before we get into the theoretical definition of row context, I'd like to just present a quick scenario which will help us understand as we move forward. We know our data set had 2 ratings fields per row. It had the subject rating and the background rating. So what is likely to happen at some point is that somebody says, hey, you know what, I'd actually like us to create a new metric which is called the overall rating of the photograph, and I'm going to define that overall rating as subject rating plus background rating. This is a very simple sort of calculation, but that's what is requested by business, by whoever our users are. So we want to be able to maybe then calculate the average of this overall rating and use that on our report as a measure. So unfortunately, the thing that we would, maybe the logical idea that we might have to just create a measure called average overall rating, which is defined as the average of the one plus the other, that won't work. DAX does not allow expressions within the parameters for the average function. And indeed, for any aggregator function, normal aggregation functions, DAX allows mainly only columns for our mathematical aggregation functions. So this won't work because in DAX, when it needs to work out this expression of subject rating plus background rating, it actually has to keep a record of which row it's in at each time to do that. And the average function doesn't have that capability. But there are ways to solve this problem, and there's 2 ways to solve this problem, but both of them rely on what we call row context. So now is the time to introduce the theory. The row context is the internal pointer within a calculation which allows the engine to know which row it is currently iterating over. So allowing because we have this pointer, the engine actually knows I'm currently looking at this row, and therefore I can do various things with the columns and the values inside that row. In the example that we're looking at, obviously it can perform that expression. Okay, so row context is created in 2 situations and only 2 situations. The first one is when we create a calculated column. So if we define a column and create it, it will, anytime that an operation happens on that column, a row context will be created inside that calculation. The other time is when we actually use an iterator function, one of the X functions in DAX. And that will also allow us to create a a row context because we specify a table or list of rows for the function to iterate over, and then we tell it what to do with each row. So let's look at the examples for each of those to solve that specific scenario. So our question here is, what's the average overall rating? And the first solution is to create a calculated column, just like that. That's step one. Step two is then to create a new measure. Well, that would be, sorry, that's the output of that column. And then step two would be to create a new measure, which is the average of our calculated column. That is a perfectly valid solution, will work very well, will do everything we expect to. But when that bottom measure is being calculated, it will create a row context for every row in the table and will allow the function to calculate the data. Okay, so that's the first solution, the calculated column solution. The second solution is by using the iterator functions. So this is a one-step solution. Previously we had to do it in 2 steps. This is a one-step solution, and it requires us to write the following formula, which is basically average x. As I said, it's an iterator function. With all the iterator functions, you have to specify the name of the table, in this case photo, and then you have to specify an expression, and our expression here is just subject rating plus background rating. When that calculation takes place within the engine, what will happen is it will go to the table, it'll determine which the table is, and then it'll go row by row and work out the various values. And then once it's got all the values, it will calculate the average. So before we move on to more advanced scenarios, let's just have a very quick look at that in Power BI so that we have an idea of how that works. So here is our row context. Now I've just put these two measures that I've created. You can see that I created an overall rating calculated column. That's the column with the definition. And then I created a measure called average overall rating calculated column, which is just the average, straight average. The other one is this iterator function. And you can see that they are bringing back the exact same result, which is expected. So we're getting the exact same result, and these two functions work exactly the same regardless of what we slice or dice our data on. So if we were to maybe put the animal on the axis, we'd get that, but they're both exactly the same. If we were to put maybe the class there, you know, we keep getting the same values as they are because those two functions are essentially doing the same or will provide us with the same result. So hopefully you understand there why we need the row context. The row context is needed because the engine has to be able to determine which row it's currently in and which row it is currently referencing for it to be able to perform something more complicated like an expression in this scenario where we're trying to add 2 columns together. Okay, so we now have a fairly good idea of our of the basic 2 execution contexts, evaluation contexts, sorry, within DAX, the only 2 evaluation contexts we have. We're now going to look at how we can use our knowledge of those evaluation contexts to make more complex or write more complex formulas that perform more complex business calculations. So the key to all of this is the calculate function within DAX. Now, I'm sure you've probably just touched on it briefly once or twice before, or taken maybe seen it somewhere, worked through it, and if you've got an understanding. Well, the important thing about the calculate function and what it's doing is it allows us to modify the filter context of a formula. So the calculate function allows us to modify the filter context. And there are multiple ways in which we can do that. We can reduce our data set by adding additional filters. We can expand our data set by removing certain filters for some reason or another, whatever our business case is, or we can shift our filter context. So we can shift our filter context to another part of our data set and bring that back and then perform our aggregation over that. And a common example of when we might want to do this is maybe when we would want to look at a same time period for last year, or look at a year-to-date value. Even if we click on a specific day and I want to see the year-to-date value, instead of it using that filter, which will reduce it to a single row or a single day's worth of data, I now actually need to make it say, actually, I need everything up to and including this day, which is a shift in our filter context. So there are all of these are just different ways in which we can modify our filter context to solve different business problems. A couple of scenarios in which we might experience this or use these calculate functions is, for instance, if we wanted to know the number of white photographs in a specific as a measure. So we always, whatever we're slicing on, we want to know how many white photographs fit into that classification. So we could do that by obviously adding in an additional slice or adding a filter on the outside of the report that says we only want to see white. But what if we want to compare the number of white photographs to the number of photographs in total based on the slicer selection or something like that? Then we can't use an external filter or an external slicer to create that. We actually have to modify the context within the calculation, and we would do it by writing a query that looks something like this, which basically says calculate for me a measure. My measure is number of photos, which is just a count, and then every parameter after that is a filter, an additional filter that you're adding to your data set. Okay, so in this case we're saying I only want to see the rows where the primary subject color is white. That's it. That's all it is to it. You can add as many of these parameters as you want after the initial measure or expression, and you can use the calculate function. You can first increase the size of a set and then reduce it again. There's loads of different ways you can play around with it. That's what the calculate function allows us to do. But it's important for us to realize that when we write a function like that, this is what will happen. We will basically have our entire data set. There are no filters on this data set right now. But when that expression is evaluated, when that measure is evaluated anywhere in a report, in a model, in Excel, wherever it is, anywhere where we do that, it will create an additional filter context, which will remove all of the non-white rows and then perform the operation. So that is how our filter context gets modified by this calculate function in this specific example. Okay, so there is an important question about that, is what happens if we already have external filters? And the answer is very useful and very nice, is that the filter context is respected and basically enhanced unless you explicitly override it. So if I have a slicer on an unrelated field and then I add in this modified filter context in my calculate, it will still respect the unrelated field, but it will add in this and also where the filter is white or the row value is white. And it'll do that for all, it'll do that for all fields unless they're actually part of the filter that we've just written. So in this case, if I were to slice on the primary color, you would actually see that it would overwrite that filter because I've got an updated filter that says this is what I actually want to look at. So we'll look at that in an example as soon as we've done with this theory. Okay. One of the other things we like to do a lot is we like to remove filters for some reason. And one of the reasons that you might want to do this is to calculate a subtotal, a total, or a grand total, or a percentage of a ratio. This is X percentage of my total data set. So there's two main functions that we can use for that. That's the all function. Well, it's one function mainly, the all function. There are others as well, all selected, etc. But the all function has two variations. One where you pass a table as a parameter, in which case it removes all filters from that table, including filters created by relationships. So if I filter on a table, a row value where I have and then I have a relationship which would then pull down into my report, that filter will also be overwritten by this all function. The other way is if you actually specify the columns. So there we say all column X, and then only filters on column X will be overwritten. Everything else will be respected. And those two usages those two overrides give us a large number of ways in which we can use this, this function to assist us in writing formula and in modifying DAX contexts. Filter context, sorry. So let's have a look at these two examples in Power BI and see what we actually can do with them. Okay, so if we start on our calculate tab over here, let me just remove a field over there so that we can do this. We're going to look at a couple of examples. So all I'm doing right now is I have my normal measure, which was count the number of rows by my filter. So my filter in this case is on the animal, on the class of animals, sorry, should I say. So I've got the class of animal and the number of photos in each of those classes. Now I want to write a couple of variations of this formula. So the first one is, let's only look at the white animals. Only look at the white photographs where white is the primary color, nothing to do with the animals. So in this case, that is the formula I would write. We sort of looked at it in PowerPoint. So what we see here is that I'm now seeing a list of all of, I'm now seeing two measures. The light blue is the all of the photos, and the darker blue is all of the white photos. You can see I haven't changed the color at all in my actual, in my slices. I haven't changed the color slices or filters or anything. I'm creating that filter context within the DAX formula. And so what's happening in this situation is if you look at our photos of raptors, we have two photos and neither of them have white. That's why we have a 0 value there. As opposed to the bears, we have two photos and both of them are white. We have the Chicago bears who play in primarily white and the polar bears who are a primarily white animal. So here we have, there is a measure we've now created which reduces our data set or adds an additional filter to the filter context and makes the data set smaller. So that's the first one. The second example we talked about was the all. So what I'm going to do here is I'm going to actually say, bring back the all photos. Sorry, there it is, the top one. All photos. So if I look at that all photos definition, you will see that I have the second part of my calculate function is all open brackets photo. So I am removing all filters, everything that is filtering the photo table at that point. And then it's counting, then it's doing our expression, which is to count the number of rows. So in this case, if we look here, you can see that in every category, I am getting the same value. Okay, so in every value, a category, I'm getting the same value. Why is that? Well, because it's not respecting that filter at all of cat. So it's counting all the rows in the table. And we know there are 12 photographs in our table. And that's exactly what is being reflected there. You can see that it doesn't matter what combination of parameters or values I put on what combination of slicing I put on, whether I slice by time of day, still that value stays at 12. Whether I filter by a subcategory, still that value stays at 12. So that calculation removes all the filters from that table, whether they're introduced from within the table or outside the table, and it takes them all away and then performs the operation. That's a very heavy sort of way to do it, but where we would usually use that is if we wanted to add in, say, a percentage where I could have a percentage of all photographs and I could maybe add that on my tooltip. Let's maybe get rid of what happens there? No, it doesn't work. So let's turn off the tooltips on that specific visual so that we get percentage of all photographs. And then when I hover over this, you will see, am I getting it? Why am I not getting it? So what the kind of thing we can do with that then is we can create a percentage of total all photographs type of measure. And if we look at that measure, percentage of all photographs, basically it is divide our normal number of photos measure by number of all photos. We would remove the filters, and we could do something like maybe put that on a tooltip. So if I find that percentage of all photos, sorry, drag it on there, put it on there. And then if I hover, you can see that I have 4 photos, which works out to 33% of my data set, 16%, etc., etc. So that's the kind of use, common business use you would have, where you want to see a ratio or a total value and work with it in that case. There's one more scenario that we might want to do. And in that scenario is we may want to remove the filter on one column, specifically one column. Okay, so let's say we have, I've done this and I've created a measure called number of photos, all categories. And what I'm basically doing is I'm saying ignore the filter on the subcategory table category column, only that one column, ignore any filters on that column. So if I do that and I add that measure into our, you'll see that currently it is respecting all of our filter contexts. Okay, it's respecting all of our filter contexts, so it's bringing back the exact same result as the light blue. In fact, let me make that easier for you to see. So you can see that we are respecting all the filter contexts. We're getting exactly the same value. What happens now if I say I only want to look at the, let's say, the cats? If I do that, what happens is I filter down my data set. Sorry, that's not. The wrong data set, James. What happens if I want to see, if I want to filter by one of these categories? So let's say I only want to see the wildlife photos, not the sports photos. If I do that, you can see that my light blue value, my original value, respects my filter context, but the dark blue actually stays with the total number of photographs. So the dark blue is in fact including the sports photographs, but the light blue is not. And that's how we can override filter context and modify and expand our data set by using filter context in our calculations. Okay, our second last section here is modifying relationships, and this is also a feature or function of the calculate function that we've just looked at, and it's one of the ways in which we can change or shift the data set, as we were talking about just now. So let's have a look at this example. For instance, on our photographs, each photograph had a class, which was a relationship. It was a table outside of the photo table that had this class in it. That class table has 5 different values, which we could use as a filter or slicer, whatever it is. What I'd like to now say is basically, based on the other filters on this data set, I want to know how many distinct classes there are. Okay, so that's an example of the kind of question I'd like to ask. In this case, what am I going to do? I'm going to say distinct count of animal class. That is the kind of formula we would write to solve this problem. Distinct count animal class. And then when I try to actually do that, let's see what happens. I get 5. That looks correct. So what happens when I add another filter on, for instance, onto the type of photograph, either amateur or professional? If I filter down to professional photographs, why is my value still 5? Because I clearly can't have 5 different class of photo. I actually only have 4 photographs. So there's definitely something not working here. So we need to think about what's going on. And in this case, the key lies in our arrow, because that filter, the relationship, is a one-way relationship, as we are supposed to model all of our Power BI relationships, or as far as possible. We're supposed to model these unidirectional relationships. So we do that. But then that means that the filter context on the photo table, on our fact table, does not propagate through the reverse direction of the relationship up into the dimension, or the class, our class table in this case. So that's a problem. So now we need to know, how do we solve that kind of problem? And there are lots of different problems like this, but this is just a simple example. So the way we do that, basically, just move that across for a bit more space, is that we write this formula. This formula is now much more complicated. Obviously, it was much more pleasant to have just a simple distinct count. But what we're doing here is we're using the calculate function to modify the context, which allows us to perform the operation that we want. So what do? Well, the first thing we need to know is this is the critical part of this formula, is the cross filter function, which allows us to define a relationship, or to use a relationship other than one that's clearly defined in our model. And in this case, what we're doing is we're using a relationship that is defined, but we're adding in that both keyword at the end of the formula of the parameters, because we're telling it to treat this as a relationship that goes both ways, a bidirectional relationship. So what we're then doing is we're saying, okay, so firstly, use that as my new data set. So cross filter, so use a bidirectional relationship, which means it then respects the relationship, the filter context on the actual fact table, then perform the distinct count, and that brings us to the correct value. That is how we can overcome this kind of problem. By modifying the existing relationship in our model, we can actually solve this problem. So there are other relationship modifiers, not going to really go through them. There's just a couple of details. If you get the slides, you can see that. Have a quick look at this example. So what I've put on this graph to start with is just split up my data set into 2 categories, amateur and professional. I have 8 photographs over there. I have 4 photographs over here. Those are my those are in fact the splits of those photographs. And now what I'm going to do is I'm going to add in a new measure, and this is my number of distinct animal classes. Now I've called it simple because I've got 2 examples that we're going to talk about. So this is the first one we looked at. All I'm doing, counting a distinct number of rows on the animal class, on the animal table, distinct number of classes, sorry. And you can see that for the 2 different categories, we have 5 animal classes over there. Obviously that can't make sense. We only have 4 photographs. How could we possibly have 5 different classes of animals? So clearly there's something not working here. So then what we do is we actually use that cross filter function that we looked at. And in fact, that is this measure over here that I've written, which says use that relationship in both directions, use a bidirectional relationship to do this calculation, and you will see what happens as I add that onto my data set. Oops, actually got to do it. There it goes. And now you can see that actually this is now working, because in my 4 photographs, 2 of them, of my 4 professional photographs, 2 of them, the British and Irish lions and the Detroit lions, talk to the same animal. So that only would bring back 1 class of animal. And that's why we are now getting back 3 classes of animals instead of that list of 5. So using that cross filter allows us to shift our filter context to include the filter context propagated through the relationship, even though it goes against the grain of the explicit relationship in Power BI. Okay, so the last sort of, we'll come back to this demo, sorry. The last thing is basically context transitions. And a context transition is a bit of a complicated concept, so we're not going to talk about it in any kind of depth. I'm just going to walk through an example. Exactly what that is it means we use the current row context of a row to create a filter context. Okay, that's a mouthful. So let's have a look at an example. Wow, that is a long formula. Let's try break it down into smaller parts. So the first thing that we need to know is we are going to be looking at the photo table. We can see this is an iterator function. So it's going to be doing something for every row. And obviously we need that because we're going to be switching a row's value to create a filter. So in that, because it's an iterator function, we need to supply a table as the first parameter. So that's our table. The next thing we do is, for the sake of clarity, what I'm doing here is I'm defining a variable. And the variable here basically says the variable is the column value for number of subjects in my photo table on the row that I am currently iterating over. So number of subjects, and then I'm then performing this operation, the calculate. And the calculate function, what is it going to do? Well, first it's going to apply the filter context. The filter context all means we remove all filters that are currently there. So look at the entire photo table. Filter back down again to the number, to all rows where the number of subjects is greater than or equal to my variable, the number of subjects on the original row that I'm looking at, the row context, and then perform the count rows. So what is this doing? Well, essentially it's saying for every row I want to create, I want to find out how many photographs have fewer, more or the same number of subjects as that photograph. And then once I've done that, I want to count those. And then after that, I want to sum up that total. So, whoa, that's a bit of a brain melt. So what we're going to do is we're going to pop into Power BI. We're going to look at this example because it's fresh in our minds. And then we'll quickly go back and look at the relationships. And that'll be the end of the talk. So, if we pop into Power BI here and we go to our context transitions, here we have, basically I'm doing this on a table because it's the easiest to visualize what's actually happening. So I've started by putting every single row on my table. Every single row in my data set is now on my table. You can see that by the fact that I have the name column, which is a unique identifier for each photograph. And I've also added in the number of subjects field over here, which shows how many subjects were in each of these photographs. So for each row, what it's doing is it's then creating a filter and getting the number of photographs that have the same number or more subjects. So this is conveniently ordered. So at 1, we include this one plus all other 11, this one plus all other 11, that one plus all other 11. Once we get to 2, we obviously start excluding those 3. That's why we're getting 9 and 9. Once we get to 3, we're excluding those 5, etc., all the way down to where we get to the last photo, the largest number of subjects. And there is only one photograph that has that many subjects or more, quite sort of obviously. But because we've wrapped that function that we actually used in an iterator, we can actually go here into our visual and remove that name and now start just by grouping by the number of subjects. So if we remember, we actually had 3 photos that all had 1 subject, and that's why we've got this number 36. 3 times 12, that gives us this value. So this measure doesn't necessarily make much sense as a business count. I don't know what you would use it for, but I just wanted to show how you can take the row context, so the value of a specific row, create a new filter context, and then use that in our calculate to perform some sort of operation. That is known as a context transition, and it's something that you do more and more as you write more and more complicated DAX formulas and as you solve more and more complicated business problems. we didn't spend too much time on some of these more complicated concepts towards the end of the session, because this was a fundamental session, but I hope you've seen some of the ideas and some of the capabilities and power of understanding and really getting to grips with filter contexts, and some of the things that we can actually do once we do know that, and what some of the ways we can modify the data sets. And I hope it's all made sense to you, and that you feel more comfortable and you've learned. Before we move on to the questions, I just have to say thank you to the contributors to Unsplash, which is where I got these photographs from, the ones that we've used in this data set. Obviously, the rest of the photos, all the wildlife photos in the sections and that were mine, but these photos were made freely available by the photographers, and I just like to say thank you to all of them and to credit them for their work. And then I'd like to thank all of you for attending the talk. I'm going to be online in a second to do some questions and take and answers. But if you want, please follow me on Twitter or send me an email if you have any questions. We may not have time for a lot of questions, but I'm available. I'm more than happy to help out. And thanks very much for attending. And I hope you have a wonderful rest of PASS Virtual Summit 2020.